This episode pulls together a few practical interpretation issues that show up constantly once regressions become richer. None of them are especially complicated on their own, but they can create a lot of confusion if we move too quickly. The main themes are standardized coefficients, functional forms like logs and quadratics, interaction terms, and the difference between r squared and adjusted r squared. Start with standardized or beta coefficients. A raw regression coefficient depends on the units of the regressor, so comparing the coefficient on income with the coefficient on years of education can be awkward if those variables live on totally different scales. Standardizing the variables fixes that by measuring both x and y in standard deviations. Then a beta coefficient tells us how many standard deviations y changes when x changes by one standard deviation. That is useful because it makes relative effect sizes more comparable across regressors. But we should be careful not to overstate what it means. A larger beta coefficient does not automatically mean a variable is more important for policy. It means the variable moves more strongly in standardized units. That is valuable information, but it is not the same thing as saying the variable is easier to change, cheaper to change, or more causally central. Next come logs. The key point is that the familiar interpretations still survive in multiple regression. In a log-log model, the coefficient is an elasticity. A 1% increase in x is associated with about a beta percent change in y, holding the other regressors fixed. In a log-level model, the coefficient is a semi-elasticity, meaning a 1 unit increase in x changes y by roughly 100 times beta percent. Those interpretations are still the backbone of applied work. Quadratic terms are where people often slow down. Once you include x squared, the slope on x is no longer constant. The marginal effect becomes beta 1 plus 2 times beta 2 times x. That means the effect depends on where you are in the data. Returns can diminish, increase, or even eventually reverse. So, whenever a quadratic term is in the model, the right question is not just what are the coefficients. The right question is what slope do they imply at meaningful values of x. That matters especially when the quadratic implies a turning point. A wage equation with experience and experience squared might say the return to experience rises for a while and then flattens or turns negative. But if that turning point occurs in a range where the data are sparse or economically implausible, the specification may be suspect. So interpretation is not only algebra, it is also a reality check. Interaction terms create a similar issue. If the model includes x1, x2, and x1 times x2, then the effect of x1 depends on x2, and the effect of x2 depends on x1. That means there is no single unconditional slope anymore. We evaluate the effect at specific values, like the mean or other practically relevant points. This is why interactions are powerful. They let the model say that one relationship changes across environments or groups. They also create a testing issue. It is possible for a variable and its interaction term to look individually weak, but together they still matter a lot for the model. That is why f-tests become especially useful here. Instead of asking whether one coefficient alone is significant, we ask whether the collection of terms involving that variable should be kept in the regression at all. Finally, fit statistics. R squared almost never goes down when we add regressors, even if those regressors are useless. So it is not a reliable tool for deciding whether a bigger model is actually better. Adjusted R squared penalizes added complexity, which makes it more useful when comparing models with different numbers of regressors. Still, even adjusted R squared should never replace economic reasoning. A model is not good just because it fits a little better. So the practical lesson is this: use beta coefficients when you need unit-free comparisons. Interpret logs and semi-elasticities carefully. Treat quadratics and interactions as statements about changing marginal effects, not fixed slopes. Use joint tests when terms belong together. And remember that adjusted R squared is usually the better comparison tool, but still only one piece of evidence. These are the kinds of issues that make regression interpretation feel more like craft than recipe. The algebra matters, but so does judgment about what the coefficients actually mean. Next, we move into asymptotics, where large sample logic starts to replace some of the exact small sample assumptions we relied on earlier.